This lecture is about missing values, and we would see some techniques on how we can manipulate missing values, and then we apply linear regression to it. So let's jump in and see of how it is being taken care of. So the first step is that import the libraries, and then we read the two data sets, the train and the test. So this is around 1460 rows, and then we remove those rows with the missing target, that is the sale price. Fortunately that there are no rows with the missing sale price, and it still remains as 1460. We divide it into two sets. So one y is equal to the sale price and the others are the features. Now what we do is that to keep things simple, we will use only numerical predictors, and so we select only those which are numeric variables by using these two lines of code. We then divide into train and test set using the train test split, with an 80% in the train and the test set being 20%. The missing values, what we would like to do is to understand what are the missing values, and we see here that we calculate the missing values by xtrain.isnal.sum, that is a missing value count by column, and this we get is there are three variables which have missing values. Now what we do is that we create one function in which we are going to score the data set, and here what we are doing is that we are creating the linear regression model. We are fitting the model to the uh, train set, x train and y train, and then we are predicting on the validation set, and then we are returning the mean absolute error. Now we would do two strategies of imputation or missing values. First is that we find the columns which have missing values by this statement, and then we find that these are the missing values that are there, and then we drop those columns which are in the train set and in the validation set. And now what we do after we have dropped those columns, that is the lot frontage, mass VNR area, and the garage year BLT, then what we do is that we get a reduced data set after we drop these columns. And you see here previously that there was 36 columns, now there are 33 columns. Now we score the data set and we find that the mean absolute error is 23831. The second strategy is using the simple imputer. So what we do in the simple imputer is that the default strategy is to take the mean of the values. So here this is a simple imputer. The default strategy is a mean. So here, so let's suppose we have this data, that is NAN 2, 3, 4, NP-NAN 6, 10, NP-NAN 9. And if I do a fit of it and then transform it, this value is replaced by the mean. So why this is 7? So we get a 7 here because 4 and 10 is 14 divided by 2 is 7. Similarly, this one we would be getting 2 because these two are 2 and therefore this is 2. Similarly, this one is all covered. So this is how we are getting this mean value. So when I'm applying the simple imputer to those values, so what we do is that we are doing the imputer. So so we are getting the imputed x train. This is the imputed x train, and the imputation removed columns, we put those columns back, and this is what we are getting. So we are imputing the columns with a simple imputer, and the simple imputer, what it does is that those not null values are being replaced by the mean of those values. And here we see that after we do this, the MSC is 23934. Unfortunately, it has not helped, but this is one of the strategies that we can use, the missing values imputation, that is replace it by mean. So hope you like this lecture of simple imputation, in which what we did was that the missing values were replaced by the mean. Thank you so much. Bye.